1,000 meters beneath the waves, the sunlight fades, colors vanish, and silence takes over like a living thing. Down here, in the pitch-black heart of our planet, exists a realm that is older than humanity and far stranger. This is not just the deep sea, it is Earth's final frontier. More people have walked on the moon than have journeyed to these depths. And yet, life thrives here in ways we can barely imagine. Creatures with jaws like steel traps, beings that glow with light they create themselves, colossal organisms that drift through eternity, never dying, always feeding. This is where the rules of life break down, where evolution writes its darkest, most alien poetry, where nothing is what it seems, and every flicker of light could mean predator, prey, or something never seen before. In this voyage, we descend past the limits of human reach to discover the strange, the beautiful, and the horrifying truths of the deep. Are you ready to dive in? Because once we go down, there's no turning back. 1,000 meters below the ocean's surface, where sunlight fades into pitch black, there lives a creature that looks like it escaped from the depths of a nightmare. This is the fangtooth. With a body no longer than a human hand, it isn't its size that terrifies scientists. It's its face, a jaw packed with oversized, needle-like teeth. It's been called the bulldog of the abyss, and for good reason. These fangs are the largest proportionally of any fish on the planet. The moment you see it, you know it doesn't belong to our world. Its armored body is sandpaper rough, almost stone-like, a natural defense forged under the extreme pressure. This is a creature built not just to survive the deep, but to dominate it. Despite its gruesome appearance, the fangtooth is small. Most adults don't grow past 6 inches, and yet it gives off an aura of something far more ancient and powerful. It looks like it belongs to a forgotten era, a holdover from the Devonian period, a time of monsters. Discovered over a century ago, the fangtooth has fascinated deep-sea biologists ever since. It dwells in the bathypelagic zone, the midnight zone, where light cannot reach and temperatures hover just above freezing. Down here, the rules of life are rewritten, time stretches, pressure crushes, and yet the fangtooth thrives. Its eyes are almost useless, reduced to tiny dots that detect only the faintest hints of light. Instead, it uses specialized pressure-sensitive pores and lateral lines across its head and body to detect movement, like a living sonar. It doesn't need sight to strike. It feels its prey. When something stirs in the dark, a struggling shrimp, a drifting fish, the fangtooth lunges without warning. Its teeth are so long and sharp, the upper jaw has evolved with special holes to store them. Otherwise, it wouldn't be able to close its mouth. Nature made no mistake here. This is a precision predator, but it doesn't chase prey over long distances. That would waste too much energy in an environment where food is scarce. Instead, the fangtooth lurks, ambushing anything that dares to get too close. It's an opportunist, a ghost in the water. Its diet includes smaller fish, crustaceans, and squid. Anything it can swallow whole. Scientists believe it uses stealth, coupled with its sensitive body sensors, to time its attack perfectly. Once those needle teeth clamp down, there's no escape. One of the fangtooth's most astonishing behaviors is its vertical migration. Every night, billions of deep-sea creatures rise toward the surface in the largest migration on Earth. And the fangtooth is among them. It may travel over 4,000 meters, all in total darkness, to feed in slightly warmer, food-rich waters under cover of night. But by morning, it returns to the abyss, to the pressure-crushed blackness where it belongs. Even stranger is its reproduction. Juvenile fangtooths look nothing like the adults. They're pale, semi-transparent, with large eyes and small teeth. Scientists think they drift near the surface as larvae, feeding and growing before slowly transforming into their terrifying adult form and sinking into the depths. But no one has ever seen them mate. No eggs have been observed, and the exact spawning grounds remain a mystery. In a world so hostile to life, the fangtooth has found a way to endure, but it has not yet revealed all its secrets. The adaptations of the fangtooth are so extreme, they've become a subject of biomimicry studies. Engineers designing submersibles and pressure-resistant materials look to creatures like the fangtooth for inspiration. How does a tiny fish survive 500 atmospheres of pressure while modern machines still struggle? Despite years of research, there's still no known footage of a fangtooth hunting in its natural habitat. All we have are glimpses, caught in submersible lights or captured in nets. It remains a shadow in the abyss, a ghost story told by the ocean itself. And that may be what makes the fangtooth so haunting. It reminds us that the deep sea is not empty. It is teeming with life. Strange, beautiful, terrifying life. And we've only just scratched the surface. It swims alone, teeth glinting in the dark. No eyes watching, no noise, just hunger. In the abyss, it is not the biggest that survives. It is the most terrifying. Deep beneath the ocean's surface, where sunlight is swallowed by the abyss, floats a creature so strange it defies our understanding of life itself, the siphonophore. At first glance, it appears to be a single long-bodied jellyfish drifting silently. But this creature is no individual. It's a colony, an ensemble of life forms functioning together as one. Each siphonophore colony is composed of dozens to hundreds of zooids, genetically identical organisms that specialize in different tasks. Some zooids are responsible for locomotion, others for capturing prey, digestion, reproduction, or defense. Together, they form one of nature's most extraordinary examples of biological teamwork. The propulsion zooids use gentle, synchronized pulses, much like jellyfish, to propel the entire colony forward. This allows the siphonophore to float slowly through the water column, conserving energy while patrolling for prey in the darkness. Other parts of the siphonophore serve as hunters, deploying long, trailing tentacles lined with venomous stingers called nematocysts. These stinging cells paralyze small fish and zooplankton instantly, allowing the prey to be pulled toward the digestive section. Some species of siphonophores can reach astonishing lengths. The Priadubia, for example, is believed to be the longest animal on Earth, measuring over 45 meters, longer than a blue whale. Its narrow body winds through the ocean like a living ribbon. What makes siphonophores truly mesmerizing is their bioluminescence. Many species emit waves of color that ripple across their bodies like undersea lightning. These displays may be used to attract prey, deter predators, or communicate between zooids. Despite their beauty, siphonophores are extremely fragile. Most species are destroyed when exposed to the pressure changes of being brought to the surface. This is why almost everything we know about them comes from deep-sea submersibles and remote cameras. One of the most remarkable aspects of siphonophore life is their reproduction. Some species reproduce sexually, while others reproduce asexually, budding new zooids to extend the colony. This dual method allows rapid adaptation and expansion in favorable environments. Siphonophores are highly sensitive to their environment. Even the slightest vibrations in the water can trigger a coordinated response from the entire colony. If threatened, they retract their tentacles and swim away in unison, a ghost disappearing into the dark. Different species of siphonophores occupy different zones of the ocean. Some float just below the surface, while others live thousands of meters deep in the bathypelagic and abyssal zones, where pressure is crushing and temperatures near freezing. Jellyfish drift like ghostly lanterns through the dark currents of the ocean. Their translucent, bell-shaped bodies pulse with an eerie grace, giving the illusion of floating through space rather than water. They've existed for over 500 million years, long before dinosaurs roamed the Earth. With no bones, brains, or hearts, their survival is a testament to nature's simplest and most efficient design. Jellyfish use specialized stinging cells called cnidocytes to capture their prey. These microscopic harpoons release venom that paralyzes small fish and plankton, delivering their meal directly to the jellyfish's central mouth. Despite lacking a centralized nervous system, jellyfish can react to stimuli such as light, water chemistry, and currents. Their nerve nets help them coordinate movement and feeding without a brain. Jellyfish come in astonishing sizes. The tiny irukandji fits on a fingertip, while the lion's mane jellyfish boasts tentacles over 30 meters long, longer than a blue whale. Bioluminescence is a superpower of many jellyfish. In total darkness, they glow with blues, greens, and even reds, using light to communicate, confuse predators, or attract prey. Some jellyfish, like the moon jelly, are gentle giants. Their sting is too mild to harm humans, and they float serenely in coastal waters, their soft pulses hypnotic and slow. Then there are the deadly ones. The box jellyfish is one of the most venomous creatures in the world. A single sting can cause heart failure in minutes. Some species have an almost supernatural gift: biological immortality. Turritopsis doornii can revert its adult cells back into a polyp state, essentially restarting its life cycle again and again. Their life cycle is complex. From tiny larvae to sessile polyps to medusas that drift in the current, jellyfish undergo incredible transformations, often unnoticed in the ocean's shadowy zones. At first glance, sea cucumbers look like squishy sausages lying motionless on the ocean floor. But these soft-bodied creatures are vital workers of the deep sea, playing a role no less important than the sharks or whales above. Despite their name, sea cucumbers aren't vegetables. They're echinoderms, closely related to sea stars and sea urchins. Their leathery skin and slow crawl hide a fascinating complexity beneath. Sea cucumbers have tubular, elongated bodies that are flexible and muscular. They move using tiny tube feet located on their underside, allowing them to crawl across the seafloor like a gentle vacuum. These creatures are the ocean's natural recyclers. They feed by scooping up sand and detritus, digesting the organic matter, and excreting the rest, cleaning the seabed in the process. They have tentacle-like structures near their mouth that act like sticky arms, grabbing food particles and shoveling them into their mouths. Slow, methodical, and weirdly mesmerizing. Some sea cucumbers defend themselves in shocking ways. When threatened, they can eject sticky internal organs, like a slimy confetti explosion, to confuse predators. Don't worry though, they can regenerate those organs over time. It's one of the many strange superpowers of echinoderms, giving sea cucumbers the ability to regrow lost body parts. Some deep-sea species, like the headless chicken monster, actually swim. With wing-like appendages and a glowing body, they hover above the seabed like bizarre underwater ghosts. Their skin is embedded with microscopic plates called ossicles, which provide structure and protection. In some species, these ossicles can harden like armor when the animal feels threatened. They breathe through their rear ends, literally. A respiratory tree connected to their cloaca allows oxygen to flow in and out while pumping water through their bodies. The flapjack octopus looks more like a cartoon than a real animal. With its big eyes, round body, and stubby arms, it seems like something Pixar would dream up for a deep-sea adventure. Its name comes from its pancake-like shape. Unlike typical octopuses, the flapjack doesn't swim gracefully. It flattens itself and drifts, flapping its arms like tiny wings. Scientifically known as Opistoteuthis californiana, this octopus is part of the umbrella octopus group. It uses the webbing between its arms to create a parachute-like shape as it moves. They are small, usually around 20 centimeters wide. Their soft, gelatinous body gives them a squishy appearance, perfectly adapted to the crushing pressure of deep-sea life. Flapjack octopuses live at extreme depths, sometimes more than 1,500 feet below the surface. Down there, light barely reaches, and the world is cold and quiet. Their big eyes help them see in near total darkness. They're not just cute, they're specially adapted to detect the slightest movement in their pitch-black world. Instead of ink for defense, some deep-sea octopuses like this one rely on camouflage and quick escapes. Their soft bodies let them squeeze into tiny crevices to hide. Their diet includes small crustaceans, worms, and other invertebrates. They float above the seabed and drop down gently, trapping prey with their webbed arms. One of the most remarkable things about flapjack octopuses is how little we know about them. Much of their behavior remains a mystery, only recently glimpsed by submersible cameras. Though it may seem like a cartoon come to life, the flapjack octopus is a real marvel of the deep, soft, strange, and built for a world we're only beginning to explore. In the crushing darkness of the deep ocean, where light never touches and pressure would flatten most life, deep-sea shrimps thrive in surprising abundance. These shrimps are not the pink ones we know from dinner plates. They are often transparent, armored, or even glowing, uniquely adapted for survival in an alien world. Many deep-sea shrimps gather around hydrothermal vents, feasting on microbes that bloom in the heat. Here, life exists without sunlight, driven by chemistry instead of photosynthesis. Some shrimps form symbiotic relationships with bacteria that live in their gills. These bacteria convert toxic vent chemicals into food, keeping their shrimp hosts well-fed. Their bodies are equipped with tough exoskeletons to withstand the crushing pressure, and their antennae serve as feelers in the total darkness, sensing vibrations and chemical cues. Some species have developed oversized eyes capable of detecting even the faintest trace of bioluminescence. Others have no eyes at all, relying entirely on touch and smell. Their survival strategies vary. Some drift slowly, catching falling organic debris, marine snow, while others are scavengers, cleaning up what predators leave behind. When startled, shrimps use a rapid flick of their tail, called the charadoid escape reaction, to launch themselves backward at lightning speed. In the Gulf of Mexico, some shrimps live along the edge of deep brine pools, extremely salty lakes on the seafloor. These edges are dangerous but rich in nutrients. In the mysterious depths of the ocean, far below the sunlit surface, lives a peculiar crustacean that looks like a cross between a shrimp and a crab, the squat lobster. Despite their name, squat lobsters aren't true lobsters. They're more closely related to hermit crabs, and they come in a surprising range of colors, sizes, and adaptations. They're called squat because of their compact, hunched posture and long, extended claws. Claws often larger than their own bodies, used to grab food or fend off rivals. In the deep sea, where nutrients are scarce, squat lobsters are often opportunistic scavengers, feeding on dead animals, organic debris, and anything edible that floats by. Some species cluster around hydrothermal vents or cold seeps, feasting on bacteria and detritus stirred up by geothermal activity beneath the seabed. Others live on coral reefs or rocky cliffs, where their claws help them hold steady in strong currents while plucking plankton or small creatures from the water. To avoid predators, squat lobsters use camouflage, tucking their bodies into rocky crevices or mimicking the textures and colors of surrounding coral and sponges. Their eyes, perched on short stalks, are keen to detect movement. If danger approaches, they can scurry backwards, using their strong walking legs, or flick themselves into the current. Though solitary by nature, some squat lobsters gather in large numbers during mating season, releasing clouds of gametes into the water column to ensure reproduction. Small but essential, squat lobsters play a vital role in the ocean's food web, cleaning the seafloor, feeding larger predators, and maintaining balance in one of the planet's darkest frontiers. Far beneath the ocean's surface, where sunlight fades and pressure soars, colonies of giant mussels thrive in the most unexpected places. Around deep-sea brine pools and cold seeps, these mussels can grow up to a foot long, far larger than their shallow water relatives, and they form dense beds that blanket the muddy seabed like underwater cities. Giant mussels don't feed by filtering plankton alone. Instead, they survive through a remarkable partnership with chemosynthetic bacteria housed in their gills. These bacteria convert hydrogen sulfide, a toxic chemical seeping from the ocean floor, into usable nutrients, allowing mussels to thrive in extreme conditions. Over time, mussel beds create micro-ecosystems. Crabs, shrimp, squat lobsters, and even eels shelter among their shells, forming complex layers of life. Unlike surface-dwelling mollusks, these mussels can live for over 100 years, slowly building up sediment-rich reefs that stabilize their surroundings. Their massive size and ability to process chemicals make them natural biofilters, helping clean their environment even in harsh chemical conditions. Mussels often grow around brine lakes, pockets of hyper-salty water that sit on the ocean floor like liquid mirrors, deadly to most marine life. Occasionally, brave scavengers like cutthroat eels slither into these zones, hunting food between the mussels, but they risk toxic shock from the salty brine. Though hidden in the deep, giant mussels are vital stewards of their ecosystem, quietly supporting life, transforming chemicals, and anchoring biodiversity in the dark ocean. As we rise from the shadowy depths back toward the light, the story of the giant mussels reminds us just how strange and resilient life can be. In places where we expect silence, there is thriving conversation, told in chemistry, in stillness, and in shell. These deep-sea survivors are proof that even in the darkest corners of our planet, life not only exists, it flourishes.